Okay, this video is for material in chapter 4. This doesn't really correspond to any section necessarily. This is just after indirect proof, but before tautologies. What I'm going to do in this video is just work through some examples of proofs that use all of the rules we've been given: inference rules, replacement rules, and also conditional proof and indirect proof. So just some examples that use all of these things. With this proof, notice that what I'm trying to derive is a conditional. Okay, if G then K. So I could use conditional proof on this. Notice, and I'm just going to emphasize this because a lot of students kind of start to get fuzzy on this after a while. You should not start a conditional proof until you can write down explicitly what the conditional is that you're trying to get. Okay? Because that will tell you then what your ACP, your assumption, has to be, and when you should stop your subproof. So if this is the conditional I want, this is going to be my ACP, so that'll be the first line. I'm going to assume G, and then I'm going to keep on deriving lines until I get K. So this is kind of what my proof will look like. This will be my subproof, and then on line N, whatever that is, after my subproof is closed, I'll have if G then K, and the justification will be lines 3 through N minus 1 conditional proof. So just my adoption of this strategy kind of determines the structure of this proof. This is what it's going to look like. Now I just need to fill in these middle lines. Okay, so here we go. Assume G. I'm just trying to derive K, and you can see how easy that is because I can get T by modus ponens on 3 and 1. I can get T or S by DI with T, and then I can get K by modus ponens. Well, that's what I wanted, was K. Remember, my goal was to assume G and then get K. So now I can close this off. If G then K, lines 3 through 6, conditional proof. Also notice this was just everything from chapter 3. This didn't even use any chapter 4 stuff. Okay. Next proof. Again, you can look at this, and there's a lot of different ways you could do this proof. You could do it without any subproofs. I think you might need the optional rule of distribution in order to do that. I'm not sure. But if you're going to use subproofs, there's several ways you could go. You could just do the negation of this whole thing, use indirect proof. You could use conditional proof. I'm going to show you what that would look like. Say, well, how can I do conditional proof to get this? This isn't a conditional. Well, remember, you can only use conditional proof to directly derive a conditional, but then you can always turn that conditional into a disjunction with conditional exchange. So if this is my last line, because this is this, what would my second to last line be? Well, it could be this, right? If I could get this conditional, if C and B then A, then I could turn it into this with conditional exchange. Right? Now this is a conditional, okay? So I can use conditional proof to get this. Well, if this, again, I'm just going to keep hammering this point. This is the conditional I want. So what is my ACP going to be? It's going to be the antecedent, C and B. When am I going to end my subproof? When I get A. So that's the antecedent. That's going to be my ACP. That is where I'm going to end it. So once I've decided to use conditional proof here, again, this sets up the whole structure of my proof. Now the only thing I don't know the specifics of is how I'm going to get from this to A. But that's going to be easy because look, I can simplify C off, get A and D, and then simplify A. So that's actually trivial. Okay. Let's go ahead and do that. So I'm going to assume C and B. So there we go, C and B. Now my goal is just to derive A. So I'm going to simplify C, then get A and D by modus ponens, simplify A off. Now I've done it. That was my goal. So now I can close this subproof off, and I'll get if C and B, then A. And now I can turn this into that with conditional exchange. And I'm done. Okay. The reason I'm sort of like doing a few examples here where I'm sort of talking through the strategy first is to try to sort of get you to start thinking that way. Instead of just sitting down with a proof and then immediately start, just cranking out random things, or just like, oh, I'm going to do indirect proof. Spend, 10 seconds, 15 seconds thinking through what your options are for how to approach it. The better you get at proofs, the faster that part will be, right? It might get to the point where you only have to spend 5 seconds thinking about it. But it might become apparent to you that one way is more promising than another way. Now here, there's a number of ways to go. Remember, we did this proof a little while ago. We used conditional proof to derive this. And then we got R with modus ponens, and then did double negation. So we use conditional proof to do this. Well, now we've got another possibility. We can use indirect proof. I'm trying to get not R. I can assume not R and derive a contradiction. So that's what I'm going to do. I'm going to assume not R, my AIP, and then try to derive a contradiction. And that's going to be pretty easy. The first thing you'll notice is this is the negation of that. It's the negation of the consequent. So I can get the negation of the antecedent by modus tollens on 3 and 4. I can't really work with a negated conditional, but if I turn this conditional into a disjunction, right, horseshoe becomes a wedge, negate the first component. I negated by taking 1 tilde off, so not A became A. Now I can work with this because I can do De Morgan's on this. I can turn this negated disjunction into what? Here's what's going to happen. It's a negated disjunction, so I'm going to do 3 things. I'm going to take this exterior negation off, wedge becomes a dot, and both components get negated. So not A will become A, and E and D will become not E and D. So that's my De Morgan's on line 6. Now I'm going to go ahead and simplify the A off of that. And I can do modus ponens on 8 and 2 to get not C. And then do DS on 1 and 9, because this is the negation of this disjunct, so I can derive the other disjunct, D and E. Now at this point, remember, I'm trying to derive a contradiction. I assume this, my goal is to derive a contradiction. Now I'm looking at this and saying, I know what my contradiction might be. If I simplify this off, I have not E and D. Here I've got D and E. Now that's not exactly, this isn't the negation of that, but it's close. If I just commute, then they will be the same statement. So I'm going to go ahead and simplify this off, not E and D. Then I can commute, well, actually, I guess first I'll conjoin them. So I'm going to conjoin 10 and 11 here. This is not exactly a statement conjoined to the negation of that same statement, because this is E and D, this is D and E. They're in the opposite order, but I can swap these with commutation. Now it is a statement conjoined to the negation of that same statement. So now I do have an explicit contradiction. So I can close my subproof off, and the next line has to be the negation of my AIP. It's not R. So here I could put R, that would be the negation of not R. I could subtract a tilde and put R, or I could add a tilde and put not R. Either way will work. I'm going to put not R because that'll end the proof immediately. But if you put R, you could then do double negation on that to get not R. That would be fine. Either way is good. Okay, so there is lines 5 through 13, indirect proof. So there are some examples of some proofs using all of the tools we've got so far. The next video is going to cover the topic of tautologies.